Hi guys, it's Miss Simon. So I wanted to make this video today to help you guys out with science. So remember yesterday we were talking about the net charge of electric fields, okay? So remember to find the net charge, we use the operation of subtraction. So if I had, say, five positive charges, five protons, and I had three negative charges, three electrons, what would my net charge be? Well, if I have five positive and three negative, my net charge is going to be two positive because I have two, 5 minus 3 is 2, and I have two more positive than negative. All right, so today we're going to actually be talking about electric fields. Remember, we talked about magnetic fields when we were talking about magnetism, and electric fields are actually going to be very similar to magnetic fields. So let me share my screen here. Remember, if I write it down, make sure you put it down in your notes, please. All right, so electric fields. So just like magnetic forces making a magnetic field, electric forces make an electric field that acts in similar ways. Okay, so go ahead and put that in our notes, please. Just like magnetic forces make a magnetic field, electric forces make an electric field that acts in similar ways. So an electric field is going to be very similar to a magnetic field. So just like a magnetic field, guys, you can't see an electric field, okay? So remember, we talked about how with the magnetic field, you don't see the lines that are around a magnet, okay? Well, the same is true for an electric field, okay? You don't see all of the lines that are around the electric charges, okay? It's invisible, but they are there. So just like the magnetic field, you can't see the electric field. But it is going to tell you whether the electric force is going to push or pull, whether the electric force is going to be attracted or whether it's going to be repelled. All right, moving on. So similar fields. The area around electrically charged items look and act similar to a magnetic field. Any item that enters an electric field will feel the force because all items have an electric charge. Okay, so no matter the item, all items have an electric charge. The lines around an electrical charge indicate the direction of the charge. So go ahead and put that down in our notes. The lines around an electrical charge indicate the direction of the charges. All right, so again, guys, magnetic fields and electric fields are going to be very similar. They look and act similar as well. The only real difference is that electric fields have positive and negative charges. They deal with charges where magnetic fields deal with north and south. Okay, so let's look at these and go ahead and put both of these pictures down in our notes. Remember, for charges to attract, they have to be unlike charges. If charges are unlike, they are attracting. So a positive is going to be attracted to the negative. And we can see that with our electric field lines here because they are pulling, they are attracted to each other. Those arrows show that it's pulling the positive and the negative together. Now remember, like charges are going to repel. They're going to push away from each other. So a positive and a positive or a negative and a negative are going to repel. And we can see that from our electric field lines here because we notice that the arrows are pushing away. They're pushing away from one another. So again, remember, like charges are going to repel. They're going to push away from each other. Unlike charges are going to attract each other. Okay, they want to find each other. All right, moving on. So there's going to be two things that determine an electric field strength. Okay, so go ahead in our notes, please. Electric field strength. The strength of an electric field is directly related to its distance and size. So distance and size are the two things that affect an electric field. And that makes sense. The closer to an electric field that you are, the stronger it's going to be, and it's going to have a greater effect. The further away you are, the less effect it's going to be, the less strong because you are further away. So the two things that relate to the strength of an electric field is its distance and its size. So go ahead and make sure you have that. Also put this in your notes. Okay, we notice here with this picture, we have strength on our y-axis, distance on our x-axis. As the distance increases, the strength we notice is going to decrease. As the strength increases, that electric field is going to increase. Okay, so if you have a higher strength, of course, it's going to be more attracted. Okay, but the bigger the distance, the less the strength. All right, let's go through these. Which of the following represents an attracting electric field? So which of those is going to be an attracting electric field? A, B, C, or D? If you said A, you are correct. A is going to be attracting because it is a positive and a negative. Okay, D will also attract, but D is a magnetic field. We want an electric field, so A is going to be correct. Electric forces and magnetic forces are example of what kind of forces? Non-contact, variable, contact, or visible. Think back to the beginning of the unit. Electric forces and magnetic forces are examples of what type of forces? If you said non-contact, you are correct. The strength of an electric field depends upon what two things? We just talked about this. The strength of an electric field depends upon what two things? Shape and number, shape and distance, orientation and size, or size and distance. If you said D, size and distance, you are correct. And the last one, when we talk about different charges attracting or repelling, we're talking about what type of force. If we're talking about charges, is that going to be a magnetic force, an electric force, or a gravitational force? If you said electric force B, you are correct. Okay, remember, if we're talking about poles, that's going to be a magnetic force. If we're talking about charges, that's going to be an electric force. All right, guys, so that is all for today. I hope that this video was helpful, and I'll see you guys later. Bye.